Hello, my fellow mathletes. We're looking at question number 18 in this video from our grade 7 Gauss paper from the year 2009. If x, y, and z are positive integers with xy is 18, xz is 3, and yz is 6, what is the value of x plus y plus z? That's an interesting question. With this amount of information, we've got 3 equations and 3 unknowns. I think we could probably actually figure out what x, y, and z individually are. Okay? It'll take a little bit of trickery, a little bit of being clever, but I think we can do it. Okay? Now, I know how to sort of approach questions like this, so if you've never seen this technique, it's something to stop and say, well, why does this work? And what we're going to do is we're going to say, all right, x times y, we know that that's 18. X times z, we know that that's 3. And y times z, we know that that's 6. Okay? We also know these guys are positive integers. That's going to play a role in just a moment. What I'm going to do is I'm going to take these first 2 equations and multiply the left-hand sides together and the right-hand sides together. So on the left-hand side, we'll get xy times xz. But if we group our x's together, we'll get x squared yz. And over on the other side, 18 times 3, that's going to be 54. And you say, okay, fine, but you've just made a more complicated looking expression. If I just wanted x on its own, I'd need to get rid of these yz's. Well, I've got yz. So if I divide both sides by 6, and we write 6 out as an actual number on the right-hand side, but 6 is the same as yz, so why don't we put that on the left? We'll get x squared is, and then 54 over 6 is 9. So this is a sort of a great technique. You can also use it if you have things like a plus b is 7, and b plus c is 9, and c plus a is 12. Adding up 2 of them and subtracting the third will usually get you the variable that's common to both of them. This only works with equations that are what are sort of called symmetric. You don't have to worry about any of that right now, but it's an interesting thing to see, and as you continue on with math contests, you will likely see more systems of equations, just variables put together in a nice way and being asked to solve for some of them. So x squared is 9. Now, ordinarily we'd say x is 3 or negative 3, but remember they said these values are positive, so x has to be 3. Great. Now, we could either do the same thing again, for example, pair these 2 together and divide by the middle one, and we'll get y squared, or we could just say, well, now I know what x is. xy is 18, but that's 3 times y is 18, and I can get y is 6. And I know xz is 3, divide both sides by 3, and you'll get z is 1. So now I can get x plus y plus z is 3 plus 6 plus 1. And that's going to be 10. And there we go. So it might have seemed a little challenging at first, and that's okay. It's question 18. It's a later question. We're almost done part B. But, if you exploit the sort of the natural pattern in the systems, we're actually able to solve for x, y, and z fairly quickly. Let's just see, 10 is answer B, so that's the one we would bubble in if we were doing the contest for real. So there we go. That takes care of question number 18. We've got 2 more to go in part B, and then we'll get to the really hard questions in part C. Feel free to leave a comment or throw a like on the video or anything like that, just to show that you're going through these contests and you're right there with me and you're practicing these things, because I really do want you guys to do better. And, hopefully you've learned a new technique if you didn't already know this sort of plan of attack from previous education. But whatever you do, I'm going to see you guys for question number 19 in the next video. So until then, have a wonderful day.